Hello students, welcome once again to our channel. Today in this video we are going to see Tamil Nadu State Board Syllabus Class 12 Physics Unit 2 Current Electricity. We have been seeing the derivations of this lesson one by one. Today in this video we are going to see the sixth derivation, the sixth question. Obtain the condition for bridge balance in Wheatstone's bridge. Now have a closer look at this diagram. This is the diagram for this Wheatstone bridge. There are four resistances P, Q, R and S, and here comes the galvanometer. This whole setup is connected to a cell. The conventional current flows from this positive terminal this way and like this, and again it comes back to this negative terminal. Now we are going to apply Kirchhoff's current rule, Kirchhoff's first rule, to the junctions B and D. Before that, what does Kirchhoff's first rule say? It says that the algebraic sum of all the currents at a junction is equal to 0. Moreover, the currents that enter a junction are taken as positive and the currents that leave the junction are taken as negative. So, what about this junction B? The current I1 enters it. At the same time, the currents IG and I3, they leave from this junction. So they are taken as negative, whereas this current I1 is taken as positive. Now let us come to this equation. Applying Kirchhoff's current rule to junction B and D. First, let us see the junction B. Here I1 minus Ig minus I3 is equal to 0. I1 is given positive sign, whereas these two currents are given minus signs. And moreover, their algebraic sum is equal to 0. Let it be equation number 1. Similarly, at junction D, we see that the current I2 enters it. This current Ig also enters the junction D, whereas the current I4 leaves it. So I2 and Ig are given positive signs, whereas the current I4 is given negative sign. Their algebraic sum is equal to 0. Now let us see the equation. This is the equation for junction D. Here I2 and Ig, they enter the junction, so they are given positive signs, whereas current I4 leaves the junction, so it is given minus sign. Moreover, their algebraic sum is equal to 0. Let it be equation number 2. Now, we are going to apply the Kirchhoff's second rule, the voltage rule, to the loop A, B, D, A. So, we have taken the path in this way from A to B, from B to D, then again from D to A. So, whatever the currents which have the direction along our path, they are taken as positive, and the currents direction which are opposite to our direction, they are taken as negative. So, here we are going from A to B, so current I1 is taken as positive, and from B to D, so current Ig is taken as positive. Then we go from D to A, but current I2's direction is opposite to our direction, so it is taken as minus. So what does the Kirchhoff's second rule say? The products of current and resistances, we need to take them first, then we need to add them all. They are equal to the sum of the EMFs at a particular circuit. So here we will take I1P, then IgG. Here the resistance of this galvanometer is taken as capital G. So IgG, then I2R. So I1P and IgG, they are given positive signs, whereas I2R is given as negative signs. Moreover, in this loop, there is no cell at all. So there is no EMF at all. So EMF is taken as 0. Now come to this equation. Applying Kirchhoff's voltage rule to loop ABDA, here I1P plus IgG minus I2R is equal to 0. Let it be equation number 3. Now let us come to the next loop, that is AB, then from B to C, C to D, again back to A. Here I1P is taken as positive and I3Q is taken as positive, whereas I4S, this I4's direction is opposite to our direction. Similarly, this I2's direction is opposite to our direction. So these two currents, I mean the products of I2R and I4S, they are given minus signs. Moreover, in this loop also there is no cell at all. So the EMF is equal to 0. Applying Kirchhoff's voltage rule to loop A, B, C, D, A, we get I1P plus I3Q minus I4S minus I2R is equal to 0. Let this equation be equation number 4. Next point is at balanced condition. What does it mean? It means when the points B and D are at the same potential. When these 2 points are at same potential, there would be no flow of current at all. That's why it is given as no current flows through galvanometer. So the current Ig is taken as 0. That is Ig is equal to 0. Now we are going to substitute the value of Ig in equations 1, 2 and 3. So it is written substituting this, that is substituting Ig is equal to 0 in equations 1, 2 and 3, we get, what do we get? We get like this. I1 minus I3 is equal to 0. Therefore, I1 is equal to I3. Let it be equation number 5. Again, I2 minus I4 is equal to 0. Therefore, I2 is equal to I4. That is equation number 6. Then, by applying the same thing in equation 4, we get, not in 4, in equation 3 we get I1P minus I2R is equal to 0. Therefore, I1P is equal to I2R. Let it be equation number 7. Now in the next step, it is written using equation 7, that is I1P is equal to I2R in equation 4. So now let us have a look at this equation 4. Here comes the equation 4. Here what am I going to do is I1P is equal to I2R. So in the place of I2R, I am going to write I1P. So I get the equation like this. I1P plus I3Q minus I4S minus I1P is equal to 0. Here what happens? This plus I1P and minus I1P, they get cancelled. So I get I3Q minus I4S is equal to 0. Therefore, I get I3Q is equal to I4S. Let it be equation number 8. Now, divide equation 7 by equation 8. So, I1P by I3Q is equal to I2R by I4S. But we all know that this I1 is equal to I3 and I2 is equal to I4 from the previous equation. So in the place of I3 I am going to write I1. In the place of I4 I am going to write I2. I1 and I1 get cancelled, I2 and I2 get cancelled. So finally what do we get? We get P by Q is equal to R by S. This P by Q is equal to R by S is the balancing condition of Wheatstone's bridge. So with this video has come to an end. Let us continue our studies with another video in the next session.
Like, share and comment and subscribe our channel and click the bell button for more videos. Thank you.